kind of a challenging trigonometric application problem. They want me to estimate the width of the Mississippi River. So the width of the Mississippi River goes from here to there. And so I am standing on top of the arch in St. Louis, which is this nice thing right here. I'm standing on top of the arch, and I can see a boat moored right here. The height of the arch is 630 feet, and I can actually see two boats. I can see one boat right here, and then I can see another boat over here. So I'm just going to erase where I drew in the arch here, because what I have right now, if I'm standing on top of the arch, I have one angle right here that my angle of depression is down to this boat over here on the Missouri side, and I have another angle over here, angle B, which combined with angle A is the angle of depression over here to this boat on the Illinois side. So looking at the problem, I'm trying to figure out, well, I know that this entire distance from here all the way to here is 2,070 feet. If I could figure out this distance right here, I can subtract that from 2,070 feet, and that would give me the remaining distance, which is what I'm looking for right there. Well, the only way I'm going to be able to figure out that remaining distance, or the way I think I'm going to be able to figure it out, is if I could only know what angle A was. If I knew what angle A was, then it would be easy for me to figure out this distance right here, because I already have a side of 630 from here to here. And if I could figure out what angle A was, I could figure out that side. So the only piece of information they're giving me is a little bit convoluted, is they're telling me that angle B, which is this angle here that I don't really need to know right yet, is the angle, the inverse cotangent of that is 67 over 55. Well, let's work with that a little bit. That means that cotangent of angle B is equal to 67 over 55. Well, that should mean that tangent of angle B is equal to the reciprocal of that, 55 over 67. So I should be able to go inverse tangent at 55 over 67, and that should get me my angle B. Well, let's go ahead and try that. I'm going to go inverse tangent, 55 divided by 67, and I find out the angle B is a 39.38 degree angle. So B equals 39.38 degrees. Let's go ahead and accept that as true and write that in here, 39.38 degrees. Okay, that's kind of helpful. How will that help me find angle A? Well, I think what I'm going to do is first I'm going to erase, whoops, let's not do that. Let's just erase these calculations. You can always go back to it on the tape. You can make some more calculations right here. I'm going to look at what I'm going to call here, I'm going to call it angle AB, the combination of these two. So angle AB, the sine, no, let's not do the sine. Yeah, let's do the tangent of angle AB. The tangent of angle AB would be equal to opposite over adjacent, would be equal to 2070 divided by 630. So I'm looking at this big triangle right here. This big triangle right there. Well, I should have done it like that, going straight across, but okay. So that big triangle is going to give me AB. So let's see. So that means that inverse tangent of 2070 divided by 630 should give me angle AB. Well, let's find out. Inverse tangent of 2070 divided by 630. So this whole angle AB, AB is a 73.07 degree angle. Well, then now we're home free, because if I take angle AB and I subtract angle B, which is 39.38.
Good afternoon, NTA.
So that gives me an angle A of, I'll subtract 39.38. And I get an angle A, I'm going to make an angle A is equal to 33.69 degrees. So angle A, 33.69 degrees, is angle A. Now I have an angle, 33.69, and a side of 630. So I can go, I want to go tangent again. I'm going to go tangent of x, which is what I'm looking for right there. So I want to have x. I'm going to go tangent of 33.69 degrees is going to be equal to opposite, which is x, over adjacent, which is 630. So x is equal to tangent 33.69 times 630. Tangent 33.69 times 630, enter, x is equal to 420 feet. So that is 420 feet. So now I can find the remaining distance just by going 2070 minus 420, 5, 1,650 feet is the answer to this problem. Just one thing I want to point out in addition. I've talked before how a trigonometric function, say for example, let's use sine for an example, has an argument of an angle, and it gives us a number. And the inverse starts with a number and gives us an angle. But let's just kind of keep going, take this back here to Sohcahtoa. Each of these are little equations, so, ka, and toa. Sine, I'm going to draw a little triangle here, a little right triangle. Sine equals the side opposite the angle divided by the hypotenuse. It's a ratio. So if this is my angle, it's the side opposite divided by the hypotenuse. That's what the number is. Cosine of theta, let's put a theta in there. Cosine of a particular angle is equal to the adjacent side divided by the hypotenuse. So this adjacent side right here has a measurement, and the hypotenuse has a measurement, and that's what gives us our number. It's just a ratio. Same thing with tangent. Tangent of theta is the opposite divided by the adjacent. It's just a ratio. Side opposite divided by the ratio. That gives us a number. So that way we can see maybe more clearly how when we use the inverse We're just switching the number and the angle, but the number, so let's say sine, inverse sine, the number is just, for example, opposite, the side opposite divided by the hypotenuse. And that's going to give us our angle. So it's kind of, the more you do this, the more you kind of realize, hey, this actually makes some sense, and it's not just a bunch of random steps that we're throwing together to make everybody miserable.